Hello everybody, I am Zach Peterson. Welcome back to my channel. Today we're going to be going over all of your questions about via in pad. We're going to talk about reliability and signal integrity, manufacturability, all of that fun stuff. Now we're going to be looking at some questions that came in on a recent video about via in pad that I published on my channel, and you can find a link to that video in the description on this video. We're also going to take a look at some comments that have come through on the Altium Academy channel on some of my videos. So this is going to be a fun look down memory lane, as well as at some recent comments y'all have sent in. So let's go ahead and get started. Now let's just dive right in. Let's take a look at this first question on my recent via in pad reliability video. Robert88KAL writes, actually several questions here. First question from Robert. Does the via fill material affect the reliability? Well, in short, the answer is yes, it can affect the reliability. One of the major ways that via fill materials affect the reliability is due to their thermal expansion. So if there is a large thermal expansion mismatch compared to copper along the z-axis, then you basically get the same effect as with a large mismatch with respect to the PCB material. The PCB material expansion in the z direction can be quite large for FR4 grade materials, and you like to minimize that as much as possible. And this is one of the reasons that many of the newer HDI buildup films and ultra HDI materials have much lower CTE values in the z-axis. It is to get a closer match to the thermal expansion coefficient for copper. Same applies for the via fill material. We want to make sure that that via fill material does not put any pressure on the cap plating on the top and bottom of that via and then create any kind of cracking during expansion events. Robert's follow-on question is also, what about through via filling and capping versus microvias? Well, comparing through-hole vias and microvias is a bit like comparing apples and oranges. With microvias, the vias on the outer layer can get filled in completely with copper and then plated over to form a planar surface for soldering, especially when you're doing small diameter vias in pad on fine pitch BGAs. So when thermal expansion occurs, you have the entire via expanding and contracting at the same rate, so you don't have this thermal mismatch problem inside the via like you would in a through-hole via that's filled with a resin. With microvias, the most common place to see a fracture is at the via ball interface or at the via-via interface when you have stacked microvias. Next follow-on question from Robert. Also, does this apply to larger pitch BGAs, since you might be forced to use via in pad there too if you are space constrained and or you are not allowed to use microvias for different reasons? Yes, it absolutely does apply to larger pitch BGAs that use via in pad. Although, of course, one of the benefits of using a larger pitch BGA is that you can try to avoid via in pad and hopefully have higher reliability by placing the via outside of the pad. Now, there are some cases relating to signal integrity where it is beneficial to put the via in the pad even though you don't need to, simply based on space constraints. I show some examples in some of my seminars relating to BGAs on components that have 56G interfaces or 112G interfaces. There you're bringing differential pairs directly into the pad so that you avoid having those small transmission lines between the bottom of the ball on the BGA package and the top pad on those vias. Also, in those designs, you're probably using very thin layers anyways, and when you're using those very thin layers on these high pin count BGAs, it's actually beneficial to use microvias, and specifically using stacked, blinded, buried microvias, because this helps you reduce the total layer count in the design. And last follow-on question from Robert. What is cheaper, through-hole plated vias in pad or dog bone microvias? This is a really great question, and I think in general you can expect dog bone fan-out microvias to cost more, or at least equal to, plated through-hole vias that are filled in pad. The reason for this is that every time you add a layer with microvias, you have to do the same processing for all of those layers. So you're adding many more processing steps in order to build a stack up with microvias than you are if you just have plated through-hole vias that you fill and cap. That means each time you add one of these buildup layers, you're adding processing costs to build the stack up. Now compare this to the case with through-hole vias. With through-hole vias, you drill the vias, plate them once, and then you fill them and cap them once, no matter how many total layers are in your stack-up. That's why you can generally expect dog bone fan-out microvias and via-in-pad microvias to cost more than a stack-up that only uses plated through-holes. This next question comes from superfan Fedi Mockney. Fedi writes, hello, is it that via in the capacitor ground pad considered a via in pad with manufacturing? The increase in the cost is large because let's take an example of a power MOSFET where you can place vias in a large pad, but I think those are not considered via in pad, correct? So I get what you're asking here, Fedi. You're essentially saying, do all of these same considerations regarding the processing cost and the reliability also apply to, for example, a large power MOSFET or a small SMD capacitor? Well, for the reliability issues, you're going to have to look at SMTA data or IPC data because they're going to be the ones to help really suss out whether or not there is a difference in reliability with those specific components. However, from the CAD tool perspective, they are definitely treated the same. You need to have a design rule that allows for placement of via in pad in order for this to prevent triggering a design rule error in your CAD software. Also, from the basic assembly perspective, they are both considered via in pad. For example, if I put a via in a capacitor pad or a MOSFET ground pad, or if I put it into a pad for a BGA, the fabricator is going to treat it the exact same way no matter which type of pad you place it in. The manufacturer is probably going to email you stating that you put the vias in pad, and then they're going to ask you if you want to have those vias filled and capped. So to conclude this answer to your question, Fedi, they're all considered via in pad no matter what type of pad they're placed in. Stuart Sommerfeld, better known as Occam's Razor here on YouTube, writes, for a 12 gigabit per second high-speed project, I checked via in pad with my trusted fabricator for BGA and connector use. He assured me that this was standard practice and would give better results than breakout using vias. Well, if better results refers to signal integrity, I think it's a little difficult to generalize whether you always get better results with breaking out using vias rather than doing via in pad. The best way to determine whether or not via in pad or breakout is going to give you better results from a signal integrity perspective is to do simulations or to do testing. And of course, you can do basic simulations involving vias with Symbior, or you can do a via impedance calculation, for example, using Polar. Either of those programs is going to help you determine whether or not you can expect better SI results at these high speeds and data rates when you're using via in pad or, for example, dog bone fan out. Next, let's jump over to our when to use via in pad video on Altium Academy. Check out this guy. He looks way too young to be doing this stuff. This first question comes from BobZG2ZF. I don't know what kind of username that is, but let's go ahead and jump in. Bob writes, I need to design via in pad now, but I have noticed that Altium 22's via types and features panel does not have any options for via in pad. So, would you please confirm if Altium 22 cannot do a via in pad design? If yes, then how do you do it? Thank you. This is a good question, and it comes up repeatedly, and I can assure you that all of the versions of Altium do support via in pad. In order to do via in pad, you need to enable a specific design rule in the PCB rules and constraints editor. So let me show you how to do this. Here I am inside Altium, and you can see here that we have a blank PCB with all of the default design rules enabled. Now what I'm going to do is open up the design menu, click on the rules option, and here you can see it brings up the PCB rules and constraints editor. Then what I need to do is scroll down here to the high speed section, and in here you will see there is an option for Vias Under SMD. Now by default there is no Vias Under SMD rule, so by default Altium will treat it as a DRC error if you place via in pad. But what you can do here is click New Rule, and then open up this option and select the new rule, and you'll see here there is a checkbox that says Allow Vias Under SMD Pads. What you want to do is click on this checkbox to enable it, then hit OK. And now if you place a via in pad in your design, it will not trigger a DRC error. This next question comes from Ritwe Moulier. Ritway writes, can I use via in pad over a dog bone fan out for higher pitch considering signal integrity? Well, I'll refer you to some of the previous answers, and the answer is yes, but of course you want to compare them in your specific stack up. There is no general rule that states that via in pad is always better than not using via in pad or than using a dog bone fan out. You really just need to compare them in your specific stack up. So again, if this is a concern that you have in your particular design, go get a copy of Symbior or at least get a copy of Polar, do some via impedance simulations, and make sure that you can do via impedance matching into the layers where you need to route traces out from your BGA. This next question on the via in pad video asks, how do I choose a via size for the exposed pad on an IC? Usually there is a suggestion for that in the datasheet somewhere, but for AD9578, I can't find anything in the datasheet. This is a really great question because the pad size will constrain the drill size that you can use to form those via in pad. As you get to smaller pitch, that of course requires you to use smaller pad sizes in order to meet clearance limits, and then that forces the drill size smaller in order to comply with your annular ring constraint. Eventually that required drill size gets so small that you're now required to use microvias on HDI buildup layers, and you'll probably need to stack and stagger them as well. Now, if you're doing via in pad, you're generally not routing traces between the pads, and that means you have some freedom to oversize that via pad just a little bit, and you can make it larger than the pad that you see in the BGA footprint. You want to make sure that you do two things. First, you want to make sure that you obey etch clearance limits between the pads in the BGA footprint or between the via pads that you're using in that BGA. That's going to ensure that you leave sufficient space between those pads so that you can etch them accurately. The other thing that you need to do is make sure that you leave sufficient solder mask dam between neighboring pads on those via in pad. That means you might want to have a negative solder mask expansion on those vias. That's going to ensure that you've got plenty of solder mask dam and that you don't have solder flow across pins and then create a short circuit. And our last question on this topic comes from Romanowski's1. Romanowski's writes, how does IPC Class 3 look with via in pad? I think there is a huge impact on reliability, but did Class 3 accept via in pad, or in other words, did any PCB house find that they're able to make PCBs with Class 3 via in pad? Well, the answer is you can do Class 3 PCBs with via in pad, but there are some requirements that you have to obey. So with Class 3 via in pad, the first thing you need to do is specify non-conductive epoxy as the fill material, and then you need to specify at least 12 micron thick copper plating over the top of that via. The second is you have to maintain planarity, and I don't actually know the planarity spec on IPC Class 3, but if you specify it for the fabrication house, they will tell you whether or not they can meet the IPC Class 3 spec for planarity on via in pad. There is also a clearance requirement for copper features. You need to maintain at least 6 mil clearance from your pad edges and any other copper features in order to be considered Class 3 compliant. Now, in addition to these three things I mentioned, the standard factors for IPC Class 3 compliant vias also apply with via in pad. One of those is, of course, the annular ring requirement. You need to make sure that there is sufficient annular ring around that drill hole after drilling, and that means no tangency and no breakout. The other thing you have to be aware of is the plating thickness on the hole walls. The hole wall plating thickness needs to be 1 mil in order to be Class 3 compliant. Now, there are a lot of really great fabricators out there that can help you figure out what are the design constraints that you need to put into your CAD software if you are designing a product to meet Class 3 standards. So make sure to contact your fabricator and get that information before you start your PCB layout.